So in this question, what I'm trying to tell you guys is what is this particular notation? This notation में क्या होता है? So we have x 3 negative, we have 48 here, and we have 22 here. So tell me what is 48?
Both sum of neutrons and protons.
Yeah, it is the mass number. Mass number को कैसे denote करते हैं? A से. And what is this 22?
Protons only.
Proton number. Atomic number denoted by Z. And what is 3 negative? 3 negative will be? Sorry, what? Charge. So what does it denote? It denotes the number of electrons added, right? Hannah? If it was neutral, it would have 22 electrons. Now it is going to have how many electrons? Tell me.
25.
Yeah, very good. 25. Now using this information, atomic structure में सबसे पहले starting में आप लोगों को पता होना चाहिए what is mass number, what is atomic number, and what is the relationship between both of them, and how are you going to calculate the number of neutrons from atomic number and the mass number. So the nucleus contains a% more neutrons than the number of electrons in the ion. What the value of A is equal to how much? Number of electron आपके पास ये होगी. What is the number of neutrons? Tell me. Neutrons यहाँ से निकालिएगा. ये A% मत लीजिएगा. 26. ठीक है. So tell me, how many percentage greater? What will be the value of A? अब maths हो गया ये, है ना? कैसे निकालेंगे? You have 26 minus 25 upon 25. Because what is A% more neutrons than the, that means what is our basis? Na comparison ka basis kya hai? Number of electrons hai. That is why we are subtracting 25 from 26 and also dividing by 25 into 100 kar dijiye. This will be equal to how much?
4%.
So the answer will be 4. Is this clear? Yes or no? Please tell me. All with you?
Yes. Sure.
Now, since we are done, let us move on to the next topic. Okay, this was just the introduction. Okay, now write the formulas for radius of atom and energy of electron in nth shell. Okay. See, both of these things are from Bohr's atomic model. Now, radius of atom, it is equal to what? 0.529 into n square. What is n here? Tell me. What is n here? Which yaad aa raha ho aapko 11th standard? Marita, once again. N is the what?
Principal quantum number.
Principal quantum number or the shell number, hai na? Shell number. Right. What is Z? What is Z?
Atomic number.
Very good. Atomic number. And what is this A0? A to the power 0. Kya hota hai? Angstrom. है ना? And 1 angstrom it is equal to 10 to the power minus 10 meters. ठीक है? So obviously the radius of a particular electron in nth shell. Okay. Radius of an atom का क्या मतलब है? आप उसके कौन से shell के radius को देखना चाह रहे हैं. So if I have first shell, that will be smaller. So it is directly proportional to the n square. Okay. So if n is greater, r will also be greater. And it is inversely proportional to the atomic number. Atomic number basically tells you about the number of proton. If number of proton is more, then it is going to attract and it is going to shrink the radius. Okay. So if this is more, then what is going to happen? The radius is going to shrink. That means it is get down. That means it is going to be smaller. So it is inversely proportional to Z. Now, just a second, guys. Okay. See here. When you have this 0.529 is going to be a constant. Let us suppose you have the ratio of one shell divided by the ratio of another shell. This will be equal to what? N1 square upon N2 square if the atom is same. Agar atom same hoga, then 0.0529, it is a constant. The atomic number will also be a constant. That means the ratio of the radiuses will be directly proportional to the ratios of the shell number only. Okay. And in general, you can also write Rn is equal to R naught, that is a constant, into N square upon Z when you have the same atom. When you have different atom, then in that case, the ratio of radii will be equal to N1 upon N2 as before, the whole square, multiplied by Z2 upon Z1. Why? Because N1 radius is what? It is inversely proportional. That is why we have Z2 upon Z1 for N1 upon N2. Okay, so please write this down. When you have two different atoms and when you have same atoms, we will do questions on both of these things. Please write this down. Please write this down. दोनों के लिए हम लोग सवाल करेंगे. Please write this down. All of you understood this relationship? Yes or no? Please tell me. N square directly proportional to N square and inversely proportional to Z.
Yes, sir.
Yes, sir.
Yes, sir.
Sir, will Bohr's radius and other constants be given in the exam?
No, then they are generally not given in the examination, but वो ना required नहीं होता है. You will see the questions right now, ठीक है ना? तो even though I have written this formula, उसको याद कर लीजिएगा आप, but generally ये इतना required नहीं होता है. जो constant है ना, उसको R naught या A naught से denote करके वो लोग वहाँ पे constant को constant ही रखते हैं. You will see the questions in the Okay, once you have written this, please see energy of electron in nth shell. Now, whenever there is a jump of electron from lower orbital to higher orbital, it is always accompanied with a change in energy. Okay, it is always going to change energy. Now, that change in energy will be corresponding to the either the light emitted if it is going from higher to lower, or the light absorbed if it is going from lower to higher. Okay, and which will be equal to h nu, and h nu, that is frequency, h into frequency, and here h nu will be equal to hc upon lambda. Let us suppose now the electron is falling back from n2 level to n1 level. Okay, n2 level to n1 level. The energy of the second level will be equal to minus 13.6 z square upon n2, whatever that n2 is, electron volts per atom, and E1 will be minus 13.6 z square upon n1 square electron volts per atom. आप electron volts को याद करके रखिए, ठीक है? And here is the conversion factor. इससे आपको क्या याद हो जाएगा? और what is the charge on electron? What is the charge on electron? 1.6 into 10 to the power minus 19. So 1 electron volt is equal to 1.6 into 10 to the power minus 19 joules. Okay, so please just remember this value. And joules में आया तो joules में आप सीधा convert कर सकते हैं इसको use करके. Now the change in energy will be equal to what? It will be equal to minus 13.6 into z square upon n2 square minus 13.6 z square upon n1 square. तो यहाँ पे क्या हो जाएगा? I will take the minus common and I will get minus 13.6 z square into 1 upon n1 square minus 1 upon n2 square. Just keep in mind n1 is the small. Okay, n1 क्या है? This will be smaller, or n2 will be larger. Okay, now you don't have to worry whether the electron is getting absorbed, it is absorbing some light, or it is emitting some light. आप इस formula को use कीजिएगा, you will get the change in energy. Okay, you will get the change in energy for both of those things. Either it is absorbing some radiation or it is emitting some radiation. If they ask you what is the wavelength of emitted radiation, तब भी आपको ये use करना है. If they ask you what is the wavelength of absorbed radiation, तब भी आपको ये use करना है. Now the question is, what is the value of h? Tell me in hc upon lambda. H की value क्या होती है?
6.60 to 10 to the power 34.
10 to the power minus or plus?
Minus 7.
6.62 into 10 to the power minus 34. This is the Planck's constant. What is the unit if you have this constant? Unit क्या होती है इसकी? What is the unit, guys?
second.
जूल सेकंड. जूल पर सेकंड नहीं होता, जूल सेकंड होता है. ठीक है, ध्यान रखिए. All of you wrote this down. Yes or no? Please tell me.
Yes, sir.
ठीक. Now, do this question. The energy of 1 moles of photon. We have 1 mole of photon of radiation of wavelength 300 nanometer is equal to how much? Calculate कर लेंगे. Energy is equal to hc upon lambda, है ना? What is h? 6.626 into 10 to the power minus 34 into what is c? What is the value of c? C का value दिया हुआ है इन्होंने. हाँ, 3 into 10 to the power. अच्छा, 6.63 बोला है ना. Wait a second. So you will take 6.63 into 10 to the power minus 34 into what is this? C, 3 into 10 to the power 8 divided by lambda. Lambda is 300 nanometer. 300 into 10 to the power minus 9. Okay, write this down. ये आपका value किसमें आएगा? This will be in joules, and then whatever value is there, you will multiply it by the Avogadro's constant. Let me tell you one shortcut here. H into C की जो value होती है, it is approximately equal to 2 into 10 to the power minus 25. ठीक है, it's approximately equal to 2 into 10 to the power minus 25. यहाँ पे minus 34 है, and यहाँ पे आपके पास क्या है? It is here 8. 34 minus 8 कितना हो जाएगा? हाँ, 34 minus 8 कितना हो जाएगा? 26 हो जाएगा. And 6.6 into 3 almost 20 होता है, 19 point something होता है. Okay, Marita. Let us see. Into 6 कर दें अगर हम. Okay, Andrea. Yeah, I think you guys are getting the right answer. Waiting for Priya. All of you multiplied it by 6.02 into 10 power 23, right? Yes or no, please tell me. Okay. कितना आ रहा है? इससे अगर करके आपको डिवाइड बाई 2 to the power 9 कितना हो जाएगा? This is 2 into 10 to the power minus 25 divided by 300 30 कर लीजिए इसको. ठीक है, into 10 to the power 10 into 6 into 10 to the power 23. है ना? So this 2s are. My bad. 2 will be here. So 400 के करीब आएगा यहाँ पे, right? So 399 is the correct answer. Write this down. HC upon lambda will be 2 into 10 to the power minus 25 upon lambda. H into C की approximate value. Approximation. See, where can we do approximation, where we can't do approximation depends on what are the options given. As you can see, the options here are they vary, they are varying a lot, right? 235, 399, 325, 435. Okay, so we can do some approximations. थोड़ा सा approximation चल रहा है. Can we move on? Yes or no, please tell me.
Yes.
Yes, sir.
Do this one. The radius of second orbit of Li2 plus is x. ठीक है, Li2 plus की second orbit क्या है? Let me just. The radius of Li, second orbit of Li2 plus is x. The expected radius of third orbit of Be3 plus will be how much? Now, for radius of Li will be equal to how much? Tell me. According to the formula, एक atom के लिए क्या लिख सकते हैं इसको? R0 लिख सकते हैं. R0 into
N square by Z.
how much? N square upon
N square by Z.
n square by z. What is the value of n for lithium? Second orbit 2 हो जाएगा ना? Right, so this will be 2, and what will be z? 3, right? And what is this value? This value is equal to how much? This value is equal to x. ठीक है? Correct guys, yes or no, please tell me. Now what will be R0? R0 will be equal to 3 by 4x. Correct, yes or no, please tell me.
Yes.
Yes, sir.
Now radius of Be3 plus कितना हो जाएगा? R0, that is 3 upon 4x into what is the beryllium? What is the atomic number for beryllium? What is the atomic
4.
number for beryllium? 4 square upon 3, right?
Yes,
कितना हो
sir.
जाएगा आंसर? What will be the answer?
Sir, how did you get 4 square by 3?
Okay, sorry, 3 square by 4 होगा, my bad. Orbit is 3 square by 4. So this will be equal to 3 cube is 27 upon 16 x, right? So option will be D. Okay, so Adil, to answer your question, you can see this constant की value उन्होंने दी भी है, समझ लीजिए, almost, right? You don't have to learn, generally speaking, you don't have to learn. अगर याद करना तो बस इसी को याद कीजिएगा, 0.5. Okay, next question in similar one. The radius of third Bohr orbit of hydrogen atom is R3 and the radius of fourth Bohr's orbit is R4. Then what is the relationship between R3 and R4? Use that formula. Rn1 upon Rn2 will be equal to n1 upon n2 का whole square. Rn1 is how much? R3 upon R4. This will be 3 का square कितना हो जाएगा? 9. 4 का square कितना हो जाएगा? 16. So R4 will be equal to how much? R4 will be equal to 16 upon 9 R3. सही है? 16 upon 9 R3. B is the correct option. Marita, Adriel, Priya, all of you got this?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. चलिए कीजिए. Assume that the radius of the first Bohr orbit of a hydrogen atom is 6 angstrom. Okay, it is equal to 6 angstrom. The radius of the third Bohr orbit of He plus will be, again you will use this formula, R is equal to Rn, rather R1 is equal to R0 into n square upon z. For R1 n क्या हो जाएगा? 1 हो जाएगा और z भी क्या हो जाएगा? 1 हो जाएगा. That means R1 is equal to what? R naught. R naught is equal to 0.6 angstrom. Okay. And then calculate what is the third Bohr orbit for He plus. The n square or z को आप लोग change कीजिए. Giving you guys how much minutes? I think 3 minutes will be enough for this. ज़्यादा हमने कर लिया. उसके बाद okay, Marita will see. पिकोमीटर में है, ध्यान रखिएगा. It is in picometers. Okay. What is 1 picometer? Marita, what is 1 picometer?
Minus 12
10 to the power
meters.
minus 12 meters. Yes, Priya, correct. Waiting for Adriel. Yes, Adriel, very good, correct. Answer कितना आ रहा है? 270. Let us see. 270. Same. Now moving on. Next topic is photoelectric effect. Okay, photoelectric effect. It basically says that if we have a metal and we hit the metal with a particular frequency, okay, if we hit the metal with a particular frequency, then the metal surface is going to eject out electrons. Then the metal surface is going to eject out electrons. Now, if let us suppose all the metal atoms, they have some kind of threshold energy. What is the threshold energy? Threshold energy is that energy which is holding back the electron. Okay, so if we, depending on the number, so if we have more number of protons, then the threshold energy will be higher, because when we have more proton, more positive charge, it will attract the electrons more effectively. If we have less number of protons, then the electrons will be attracted less effectively. Okay, the threshold energy, each electrons, depending on what metal we have. Okay, depending on the metal, we have the threshold energy. It is given by h mu naught. This is the threshold frequency. This is the threshold wavelength. Now, whatever photons energy I am going to hit, some of it will be used for the threshold energy. It is also known as work function. That is why it is denoted by W. And if there is any other energy, which is remaining, then that energy will be used for the kinetic energy of the electron. Okay, so sometimes basically जो भी सवाल आता है, it is mainly on kinetic energy. So kinetic energy will be equal to h nu. Here nu is the frequency of the photon that you have hit. Mu naught is the threshold frequency, and that is why the kinetic energy mass is equal to the energy of photon minus the work function. We can also write half mv square. Sometimes they will ask you the velocity. So half mv square will be equal to hc upon lambda minus hc upon lambda naught. This lambda naught is for the threshold frequency. Now hc will be common, and we can write lambda naught minus lambda upon lambda into lambda naught. Okay, so this lambda is what? The wavelength of radiation that hits metal. ठीक है, ये lambda क्या है? The wavelength of radiation that hits metal. What is this lambda naught? Lambda naught आपका क्या है? This is threshold wavelength. Okay, please write this down. Let me know once you're done writing.
Sir, is it necessary for us to by heart the atomic number of elements from D block or
Till 30.
F block?
Atomic number till 30. Okay.
Sir, but
again,
actually,
नहीं हम बता रहे एटॉमिक नंबर टिल 30. दिस इज इंपॉर्टेंट. अब उसके बाद कभी कभी वो पूछ देते, फॉर एग्जांपल आई थिंक देयर वाज वन क्वेश्चन, व्हाट इज द नंबर ऑफ प्रोटॉन समथिंग फॉर Nd2+ और द
yes,
इलेक्ट्रॉनिक कॉन्फ़िगरेशन ऑफ Nd2+. you cannot do anything in that. अब सब फिर तो they're asking you to remember everything, right?
yes, sir.
But अगर आप 30 तक याद करके जाइएगा, देन दिस विल बी यूज नॉट ओनली, ये तो सिर्फ Nd2+ का कहाँ पे काम आएगा, अगर इन्होंने इलेक्ट्रॉनिक कॉन्फ़िगरेशन पूछ लिया एफ ब्लॉक एलिमेंट का, तब वहां पे काम आएगा, है ना. एफ ब्लॉक एलिमेंट से दे आस्क इलेक्ट्रॉनिक कॉन्फ़िगरेशंस ओनली. ओके, एफ ब्लॉक एलिमेंट्स और कुछ नहीं पूछते, दे ओनली आस्क अबाउट द इलेक्ट्रॉनिक कॉन्फ़िगरेशन. तो एफ ब्लॉक का आप याद कर सकते हैं, अदरवाइज ऐसा नहीं कि पूरा पीरियोडिक टेबल का जरूरी है. हाँ, बट यू हैव टू रिमेंबर द एटॉमिक नंबर एंड द मोलर मासेस ऑफ द फर्स्ट 30 एलिमेंट्स. दिस इज नॉट ओनली बी यूज्ड डायरेक्टली फॉर द इलेक्ट्रॉनिक कॉन्फ़िगरेशन, लेकिन इनडायरेक्टली मोलारिटी कैलकुलेट करने में, नंबर ऑफ मोल्स कैलकुलेट करने में, नंबर ऑफ अनपेड इलेक्ट्रॉन्स कैलकुलेट करने में, कोऑर्डिनेशन केमिस्ट्री में हाउ मेनी इलेक्ट्रॉन्स आर देयर इन द डी सबशेल, उसको कैलकुलेट करने में वहां सब जगह इस्तेमाल होगा. ओके, एफ ब्लॉक एलिमेंट्स के लिए यू कैन रिमेंबर द एटॉमिक नंबर एंड द इलेक्ट्रॉनिक कॉन्फ़िगरेशन, करस्पॉन्डिंग इलेक्ट्रॉनिक कॉन्फ़िगरेशन. ठीक है मरीता?
Yes, sir.
एंड दिस Nd2+ इज फॉर एफ ब्लॉक एलिमेंट्स, वो एटॉमिक स्ट्रक्चर में नहीं होना चाहिए. ओके.
Okay, sir.
Okay, I hope you are done writing this down. Write this question now. This is easy. The minimum energy that must be possessed by photons in order to produce photoelectric effect with platinum metal. ठीक है? The threshold frequency of platinum is this much. उन्होंने threshold frequency दे दिया. That means what they have given. H nu दिया हुआ है आपको. H nu आपको क्या दिया हुआ है? You have been given the nu frequency. You just need to multiply this by h and you will get the threshold frequency. Mu naught दिया हुआ है, आपको क्या मिल जाएगा? W मिल जाएगा. That is threshold frequency. Do this. आई थिंक पावर्स को ही आप लोग कैलकुलेट कर लीजिएगा, आंसर आ जाएगा. 34 - 15 कितना हो जाएगा? माइनस ये 19 हो जाएगा ना. दिस इज 19 राइट. नो, दिस इज -34 है, तो -19 वाला करेक्ट ऑप्शन होगा. सी ऑप्शन आ रहा है. व्हाट अबाउट अदर्स? सी इफ यू हैव एक्सपोनेंट्स में ही अगर डिफरेंस है तो सिर्फ एक्सपोनेंट्स को कैलकुलेट कर लीजिए, आगे कैलकुलेट करने की जरूरत नहीं. यस, विल गेट द आंसर as C. Write this question. Okay, so हो जाएगा ना? प्लीज टेल मी गाइस, आप लोग कर पा रहे हैं? Let me give you 4 minutes for this. कंसेप्चुअली अगर दिक्कत आ रही है, आपको समझ में नहीं आ रहा कौन सा फॉर्मूला यूज करना है, तो फिर लेट मी नो। हाफ mv स्क्वायर वाला फॉर्मूला यूज कीजिए। Anyone got the answer? Okay, no one. Can you please stop writing and tell me what you have done till now? Yes, Atril, tell me which formula.
Calculator.
Which formula you have done? You have taken which formula?
So the kinetic energy hc by lambda minus that one, half mv square formula.
hc upon lambda minus
Minus
hc
hc by
upon
lambda
lambda
naught.
नॉट, ठीक है ना? काइनेटिक एनर्जी हो जाएगा आपका हाफ mv स्क्वायर, mv square. अच्छा, hc upon lambda, this is corresponding to the radiation, है ना? तो metal surface का radiation कितना हो जाएगा? hc upon lambda is 500 into 10 to the power minus 9. hc का हमने क्या बोला था? What is h? अच्छा, hc को आप कॉमन ले लीजिए यहाँ पे, and then they have given lambda not नहीं दिया हुआ इन्होंने, क्या दिया हुआ यहाँ पे? hc upon lambda minus h mu naught दिया हुआ है, right? This is the frequency. सही है? कैसे पता चला फ्रीक्वेंसी है? उन्होंने बोला है ना थ्रेशोल्ड फ्रीक्वेंसी, राइट?
Yes, sir.
ओके, नो लेट अस कैलकुलेट. यहाँ पे hc अपॉन लैम्डा है, तो hc विल बी 2 into 10 to the power minus 25 अपॉन लैम्डा इज 500. इसको 50 लिख के 500 into 10 to the power minus 9, है ना? तो 50 into 10 to the power minus 10 कर सकते हैं, राइट? तो 50 into 10 to the power 10 कर दिया हमने, माइनस h यहाँ पे आपके पास 6.63 into 10 to the power minus 34 into what is mu naught? It is 4.3 into 10 to the power minus 14. इसको अच्छे से करना पड़ेगा. So you have 2 into 10 to the power minus 15 by 50 minus 6.63 into 4.3 into 10 to the power minus 20. minus 20 हो जाएगा. करेक्ट गाइस? ऐसा नोटेशन में कोई दिक्कत? नो प्रॉब्लम, राइट?
No, sir.
नो प्रॉब्लम. ओके, यहाँ से हाफ mv स्क्वायर है ना, तो लेट अस सपोज स्क्वायर से कर देते हैं. 2 into 10 to the power minus 15 minus 50 into 6.63 into 4.3 into 10 to the power minus 20. Lack of space. 2 into 10 to the power minus 15 minus 50 into 6.63 into 4.3 into 10 to the power minus 20 whole divided by 50 हो जाएगा ये, सही है? And this thing, it will be multiplied by what? It will be multiplied by 2 divided by what is the mass on electron? Mass on electron is equal to 9 into 10 to the power minus 31. सही है? Yes or no, please tell me, guys.
Yes, sir.
Okay, now we have to calculate this thing. So 2 into 10 to the power minus 15, इसको calculate करना पड़ेगा पहले. 6.6. Anyone calculate that part? 50 into 6.63 into 4.3. This is 2 into 10 to the power minus 15 minus 1425.45 into 10 to the power minus 20 divided by 50 into 2 upon 9 into 10 to the power minus 31. तो 1 2 3 4 ऐसे कर सकते हैं. 2 into 10 to the power minus 15 minus 0.0142 into 10 to the power minus 15 divided by 50 into 2 upon 9 into 10 to the power minus 31. यहाँ तक सही? Any problem till here?
No, sir.
minus 20 है ना, तो 5 प्लेस हमने इधर कर दिया, राइट? सही किया ना हमने? ऐसा नो, राइट ओनली ना?
Yes, sir.
ठीक है, सो इसको हम कर सकते हैं 2 minus 0.0142 is equal to 1.98 upon 50 into 10 to the power minus 15. minus 15 को हमने कॉमन ले लिया था यहाँ से, दोनों में से, into 2 upon 9 into 10 to the power plus 31. कितना हो जाएगा ये? 1.98 upon 50 into 2 by 9 into 10 to the power 31 minus 15, 10 to the power 16 हो जाएगा. सही है? ये सर प्लीज चल
Yes,
गई.
sir.
ओके, तो ये हो जाएगा आपके पास 9 5 से कितना होता है 45, 9 into 5 50 is equal to 450 root of 450 अप्रोक्सीमेट, अच्छा इंटू 10⁵ पे इसमें आएगा ना। ओके इसको 4 मान लेते हैं, 4/9 5 450 और ये हो जाएगा दिस अंडर रूट इंटू 10⁴ करेक्ट। नहीं 10⁸ होगा,
Yes.
नहीं सॉरी, नहीं एक सेकंड, दिस विल बी 10⁸ ना। 16 का रूट क्या हो जाएगा, 16 का आधा 10⁸ होगा, मैं बैड या 4/450 कितना होगा। कैलकुलेट दिस, कैलकुलेशंस में काफी लंबा चला जाएगा आई थिंक। Hmm, 93 into 10⁵. (93) और रूट 93 में भी नहीं आएगा आंसर। ओके
I got just 93.
93 नहीं, 93 is not right. This is our problem now, 4/450.
Sir, the threshold frequency is in hertz. Do you have to convert that?
नहीं हर्ट्ज इज पर सेकंड होंगे ना, उसको कन्वर्ट करने की जरूरत नहीं थी। I am also getting similar value only. There's some mistake we are doing. अच्छा एक काम कीजिए, लेट अस इसको भी ऐसे रखिए, इसमें कैलकुलेशन में कहीं कुछ हो रहा है। Do this question, meanwhile I am doing that question. Do this one. A source of monochromatic radiation of wavelength 400 nanometer provides 1000 joule of energy in 10 seconds. When the radiation falls on the surface of sodium, x into 20 electrons are ejected per second. Assume the wavelength 400 nanometer is sufficient for ejection of electron from the surface of sodium metal. The value of x is equal to how much? Okay, first of all, see when since they are asking per second, 1000 joules of energy in 10 seconds, that means energy per second कितना हो जाएगा? 1000/10, that is equal to 100 joules है ना? तो 100 joules energy लेके चलिएगा आप। Let me do this one.
So what equation do we use for this?
For this one, they're giving you this many joules of energy, huh? And per second it is ejecting the x into 10 to the power 20 electrons are ejected per second. First of all,
So shouldn't they get the threshold frequency of sodium?
threshold frequency is given 400 nanometer.
So then ejection will not take place, right?
Ejection will not take place. See here, a source of monochromatic radiation of wavelength 400 nanometer provides 1000 joules of energy in 10 seconds. Okay.
Yes, sir.
So 400 nanometer की तो आपके पास wavelength है, and 400 nanometer is enough to eject the electron, correct?
Okay, sir. So it means there's no kinetic energy.
There is no kinetic energy, only ejection is there.
Okay, sir.
See, you have to calculate the energy required for the ejection of electron. Okay? And whatever energy you are getting, you will divide that energy by 100. 100 upon that energy. That will give you the number of electrons. See here, guys. What is the energy that is required? The work function is equal to how much? The work function will be equal to hc upon lambda naught. hc will be 2 into 10 to the power minus 25 divided by lambda naught कितना है आपके पास 400 nanometers, right? Sufficient. So 400 into 10 to the power minus 9. So ले सकते हैं 2 upon 400 into 10 to the power minus 25 into 10 to the power plus 9. कितना हो जाएगा ये? 2 upon 400 into 10 to the power minus 16. Correct till here? Yes or no? Please tell me.
Yes, sir.
Anyone? Any doubt till here? No, no.
No, sir.
Okay. So this is the energy that is required to remove one electron. और आपको in 1 second, I am getting 100 joules of energy, right? So in 100 joules of energy, कितने electrons निकल जाएंगे? 100 upon the energy required for removing one electron is equal to 2 upon 400 into 10 to the power minus 16. So will be equal to 400 ऊपर चल जाएगा. 100 into 400 into 10 to the power plus 16 divided by 2. ये हो जाएगा आपके पास 200, right? So 200 into 1 कितना हो जाएगा? 21020. 20 यहाँ 20 यहाँ into 10 to the power 16. This will be equal to 2 into 10 to the power 20. सही है? So what will be the value of x? X की value जाएगी 2. Got it, guys? Yes or no? Please tell me. Adriel, Marita, Priya, all of you.
Yes, sir.
Yes, sir.
Okay. Adriel, आपको समझ में आया?
Yes, sir.
Okay. Now, right next, the hydrogen spectrum. So, थोड़ा सा और है. I'm just removing this, okay? Okay. Now in hydrogen spectrum, you have to remember it like this: LB PBP. LB PBP. Okay, LB PBP याद कर लीजिए. So you have Lyman, Balmer. इसमें 1, 2, 3, 4, and 5. That means whatever electron, if the electron is coming and it is going to the first shell, then it will be Lyman. Second में bar, third में Bastian, then bracket, and then P. Okay, LBPB, and in this, the Balmer series is important because it is inside what? In the visible region. Directly एक बार सवाल आ चुका है. The Balmer region is for the visible region. Now, how to get the wavelength? So for that we have this formula: 1 upon lambda is equal to r into z square. This is for any element. Okay, this is for any atom. Okay, this is for any atom or hydrogen like atom. हाइड्रोजन या हाइड्रोजन लाइक एटम. अगर आप लिथियम का निकाल रहे तो लिथियम प्लस में देखना होगा आपको, लिथियम 2 प्लस में देखना होगा, हीलियम में देखना होगा आपको. ओके, so the wavelength will be calculated by r into z square upon 1 upon n1 square minus 1 upon n2 square. R is equal to 109677 centimeter inverse. This unit is very important. Generally unit आपको wavelength का दिया रहेगा nanometer angstrom में, centimeter से आपको convert करना पड़ेगा. You will get this answer in the form of centimeter inverse. Okay, lambda का यहाँ से आंसर कैसा आएगा? सेंटीमीटर में आएगा. You have to convert it to nanometer angstrom according to the options. N1 is the lower energy level, N2 is the higher energy level, and Z is the atomic number. Now, lambda max will be attained when you are moving from, if n is equal to 1, then n2 should be equal to n plus 1. Okay. Lambda max कहाँ पे आएगा? Lambda max आएगा आपके पास n1 जब क्या हो 1 हो और n2 क्या हो n plus 1. For example, if I talk about the lambda max in Lyman series, so what will be n1? That will be 1, and what will be n2? That will be 2. For Balmer series lambda max क्या हो जाएगा? 2, और ये n2 will be 3. Balmer series के लिए lambda max. एक सेकंड, n1 को आप n1 will be n1 and n1 will be n. ये लिखिए, n1 will be n and n2 will be n plus 1. Okay. Now moving on, the total number of spectral lines that you are going to get. Okay, so if the electron is jumping ground energy level to the nth level, या nth level से ground energy level में आ रहा है, then the total number of spectral lines will be n into n minus 1 upon 2. You have to remember this. Okay, if it is jumping, अगर उन्होंने नहीं दिया, उन्होंने सिर्फ ये बोला कि fifth से ground में jump कर रहा है. Okay, then how many spectral lines? n into n minus 1. What is going to be the n? N will be 5. ठीक है. Now, if it is going from n2 level to n1 level, जैसे उन्होंने बोला 5 से कहाँ jump कर रहा है? Let us suppose 3 में jump कर रहा है. Then the formula will be n2 minus n1 into n2 minus n1 plus 1 divided by 2 as above. Now, if there is only single electron, एक ही electron, in all of these other cases, single electron या फिर single atom की बात अगर हम करें, in this case, this is for single electron और single atom. एक एटम में, हाइड्रोजन की एक एटम में क्या होगा? हाइड्रोजन या हाइड्रोजन लाइक एक एटम में एक ही इलेक्ट्रॉन होगा. ओके, सो इन दैट केस the maximum line will be is equal to how much? It will be equal to n minus 1. For example, आपके पास एक ही इलेक्ट्रॉन है, तो फिफ्थ लेवल में है ये 1 2 3 4 and 5 फिफ्थ लेवल में है. तो व्हाट इज द मैक्सिमम लाइन? ये 4 से 5 जा सकता है, 5 वाला 3 में जाएगा, 3 वाला 2 में जाएगा और 2 वाला 1 में जाएगा. सो हाउ मेनी लाइंस आई एम गोइंग टू गेट? 1 2 3 4. Simply speaking, 5 minus 1, that is n minus 1. So if you have single atom or if they are saying there is single electron, तो फिर कितना होगा? n minus 1. And what is n? N is the current energy level. यहाँ पे भी वो the current shell number. Please write this down. Simple सवाल आते हैं इसमें. Done writing this? Yes or no? Please tell me.
1 second, sir.
Okay.
Done, sir.
Okay. Now, the region in electromagnetic spectrum where Balmer series lines appear is Balmer series कौन से में आता है? Visible में आता है ना? Directly इसका आंसर आपको आना चाहिए. C option here. When the excited electron of hydrogen atom from n1, n is equal to 5, drops to ground state, the maximum number of emission lines absorbed are what? कितना हो जाएगा बताइए?
4.
नहीं, सिंगल नहीं बोला ना उन्होंने.
Okay.
हम समझ रहे हैं, आप ए देख के आप सोच रहे हो. हाँ. It will be equal to how
So
much?
10.
हाँ, 5 into 5 minus 1 upon 2, that is equal to 10. ठीक है? n into n minus 1 upon 2 is the formula. ये बताइए, which transition in the hydrogen spectrum would have the same wavelength as Balmer type transition from n is equal to 4 to n is equal to 2 in He plus spectrum? दोनों का 1 upon lambda लिखिए, 1 upon lambda for He plus जहाँ पे n2 is equal to 4 and n1 is equal to how much? 2. फिर लिखिए 1 upon lambda for hydrogen. टेल मी व्हाट विल बी फॉर एच, एच ई के लिए क्या होगा, एंड देन टेल मी फॉर एच। 1 upon lambda will be equal to, tell me guys, HE plus के लिए कितना हो जाएगा, R the Rydberg's constant into z square means 2 का square into 1 upon 2 का square minus 1 upon 2 का square minus 1 upon 4 का square. This is for HE. 1 upon lambda for hydrogen will be equal to R into 1 का square 1 upon n1 square minus 1 upon n2 square. ठीक है, देखिए इसे क्या लिख सकते हैं, R इंटू 4 इसमें मल्टीप्लाई होगा तो 4 upon 4 minus 4 upon 16. सही है, yes or no, please tell me guys.
Yes, sir.
तो इसको क्या लिख सकते हैं, R 1 upon 1 minus 1 upon 4 लिख सकते हैं, yes or no, please tell me guys. अरे हाँ ना, कुछ तो बोलिए। ठीक है,
Yes.
इसको क्या लिख सकते हैं, R इंटू 1 upon 1 का स्क्वायर माइनस 1 upon 2 का स्क्वायर, है ना। अब दोनों को कंपेयर कर लीजिए, n1 स्क्वायर क्या हो जाएगा, 1 का स्क्वायर एंड n2 स्क्वायर विल बी 2 का स्क्वायर, तो n1 इज इक्वल टू 1 एंड n2 इज इक्वल टू 2। कौन सा ऑप्शन सही हो जाएगा, 2 to 1, करेक्ट, yes or no, please tell me.
Yes, sir.
B option is correct, 2 to 1, higher से smaller, है ना, greater से smaller. Adriel and Priya understood this, yes or no, please tell me.
Yes, sir.
Yes, sir.
Tell me about this. The shortest wavelength of hydrogen atom in Lyman series is lambda. The shortest wavelength of hydrogen atom in Lyman series is what, lambda. Shortest wavelength कहाँ पे होगा, tell me. Shortest wavelength के लिए what will be the
Infinity
n1
to
and
n is equal to 1.
n1 is equal to how much and n2 is equal to how much? n1 is
N1
equal
is
to
1
how much?
and 2 is infinity.
ठीक है, the longest wavelength is the longest wavelength in Balmer series होगा, in Balmer series of Hg plus will be equal to how much? फिर से आपको वही करना पड़ेगा, first of all is for hydrogen, 1 of lambda hydrogen will be equal to R into 1 का square upon 1 upon 1 का square minus 1 upon infinity square, correct, yes or no, please tell me. And then
Yes.
1 upon lambda He के लिए क्या करना पड़ेगा, will be equal to R into 2 का square. अच्छा, what Balmer series के लिए n2 क्या हो जाएगा,
2.
है ना, 2, n1 will be 2 and n2 कितना हो जाएगा, n1 होगा ना 2, n2 will be longest wavelength है,
3.
3.
n2 will be 3, है ना। तो यहाँ पे कर देंगे 1 upon 2 का स्क्वायर माइनस 1 upon 3 का स्क्वायर, राइट। 1 upon infinity तो 0 हो जाएगा, सो आई कैन राइट दिस एज, आगे सॉल्व कीजिए आप, आगे सॉल्व कीजिए थोड़ा। This will be equal to, this is 0, 1 minus 0 will be 1. ये तो सिर्फ r हो जाएगा. Okay, r and r will cancel out each other. 4 upon 9. Marita is getting option. Okay. I think that is correct. इन दोनों को अगर डिवाइड कर दें हम, so I will be getting denominator of denominator will be numerator. HE upon lambda will be equal to, yes, Priya, I think that is correct option. Nine minus 4 is equal to 5. 5 upon 9 into 4. 4 तो cancel हो जाएगा. So you'll have here 5.9 और यहाँ पे 1 हो जाएगा. Lambda HE will be equal to 9 upon 5 lambda. If you solve this, you will get 5 upon 9. यहाँ पे 9 minus 4 upon 9 into 4 and 2 का स्क्वायर कितना हो जाएगा? 4. 4 और 4 cancel. You will get 5 upon 9. 5 upon 9 को आपने नीचे रखा, 9 ऊपर चला गया, 9 upon 5. So option C is the right answer. Adriel, आपसे हुआ? Marita and Priya got the right answer.
Yes, sir.
Okay. Now moving on, you have de Broglie wavelength. What is de Broglie wavelength? De Broglie said that if you are in the third shell, then you will have a wave which will have 3 lambdas. Okay, which is going to have a wavelength. What? There will be 3 lambda will be the circumference यहाँ पे. If there is 4, तो वहाँ पे कितने waves होंगे? 4 waves होंगे. 4 waves यानी कि 4 lambda. If you have 5, that means there will be how many lambdas? 5 lambdas उसका circumference होगा. Now I can write here from this 1 lambda, 2 lambda, 3 lambda, यानी कि the circumference is equal to what? N lambda. So 2 pi r n, n is here what? The shell number will be equal to n lambda. Okay. So this is basically the de Broglie's wavelength. यहाँ से आपको de Broglie wavelength निकल जाएगा. Rn कहाँ से निकालेंगे? Rn you can calculate from the Bohr's radius. Rn is what? It is the Bohr's radius, or lambda क्या? This is de Broglie wavelength. Please write this down and then write this question. The de Broglie wavelength of an electron of the 4th Bohr orbit. ठीक है. और यहाँ पे a0 क्या है? It is a radius of first orbit of hydrogen. जो हम लिखते हैं ना, Rn is equal to R0 into n square upon z. हाइड्रोजन के फर्स्ट ऑर्बिट के लिए क्या हो जाएगा? n will be 1 and z will be 1. So Rn will be equal to R0. तो यही यहाँ पे a0 है. जब भी you will see a0, R0, n0 इस तरह से कुछ दिया रहे तो आपको रेडियस ऑफ फर्स्ट ऑर्बिट ऑफ हाइड्रोजन मानना है. कैलकुलेट दिस. यू जस्ट नीड टू प्लग इन दिस वैल्यू यहाँ पे. ठीक है. So radius of the 4th orbit will be equal to how much? It will be equal to a0 into n कितना हो जाएगा? 4. 4 का स्क्वायर कितना हो जाएगा? 16 अपॉन बोर ऑर्बिट बोला हाइड्रोजन के लिए तो हाइड्रोजन ही हो गया वो. ठीक है. So a16 हो जाएगा ये. Then lambda will be equal to 2 pi into Rn कितना आ गया आपके पास? 16. a0 16 divided by n is equal to 4. What will be the answer? समझ में नहीं आया क्या आप लोगों को? Adriel, Priya, what happened? Marita, what happened?
So option C.
I think that is correct. Yeah. See here, guys. Okay. Rn क्या हो जाएगा? Rn will be equal to a0 into n square upon z. What is n? For the 4th orbit, it will be equal to how much? 4 square. So a0 into 4 square. I can also write 2 pi Rn is equal to n lambda. ठीक है. तो यहाँ पे Rn की वैल्यू क्या है? 16 a0 है ना. 4 का स्क्वायर कितना हो जाएगा? 16 a0 is the value of Rn into 2 pi is equal to 4 lambda. Now lambda will be equal to how much? 2 pi 16 a naught upon 4. 4 से 4 this will be equal to 8 pi a naught. Okay, so the answer will be C. Understood, guys? Yes or no? Please tell me. Adriel
sir.
and Priya, got it?
Yes, sir.
Okay. Next, we have quantum numbers and electronic configuration. इसमें there is no theory. I hope quantum numbers और electronic configuration में as soon as you see question, hopefully आपको आ जाना चाहिए. So starting with this particular thing, isoelectronic configurations, isoelectronic species. You have been given all the atomic numbers. और आपको यहाँ पे बताना which of them are isoelectronic. Isoelectronic means same number of electrons. मरीता, आप याद करके बैठी हुई हैं क्या? हाँ मरीता.
No, sir. The others are from different periods, right? So
Others
only
are from
these
different.
are the elements. Sorry, only D option elements are in the same period, so their ions will have isoelectronic configuration.
नहीं, they are not from the same period. Potassium और chlorine same period से हैं.
No, chlorine is in the other period, but its atomic number is 17, so
हाँ
it
ठीक है, but this हाँ ठीक, I understand that, but still. First of all, let us see the first one. N3 negative, O2 negative, F negative, all of देखिए basically ऑक्सीजन पे 2 नेगेटिव चार्ज होने पे क्या होता है? जनरली O पे 2 नेगेटिव चार्ज होता है. जनरली नाइट्रोजन का क्या होता है? व्हाट इज द ऑक्सीडेशन स्टेट ऑफ नाइट्रोजन? इट इज 3 नेगेटिव. इस तरह से सोच के चलिए आप लोग. ओके, एंड इन द सेम पीरियड इट विल बी ओके. N3 O2 and F negative सही है. S2 negative is also right, जो कि इसका होता है, but it is from this it is from the another period. Okay, so that is why this is not having the same electronic configuration. Lithium positive and Na positive, obviously these two are from different groups. और दोनों में क्या है? Positive charge है. That is why they are not going to have. These are from different groups, है ना? और दोनों में same charge है. तो obviously इन दोनों का तो सही होगा ही नहीं, same होगा ही नहीं. Similarly, barium and strontium, they are from what? Different period but same group. Different period और same group का कभी भी isoelectronic species नहीं बन सकता. Please cut this. ठीक है? Now here we have potassium, then chlorine. Potassium plus means how much electron? Potassium plus means 18 electrons. Chlorine minus also means 18 electrons. Potassium के बाद आता है calcium में 2 plus, उसके बाद आता है scandium, right? तो लगातार अगर आपके पास आ रहे हैं, then it is going to be the right answer. Okay, all of these are going to have 18 electrons. You can count it. Basically count करके ही करना पड़ेगा. जिसको जल्दी से count करने आ गया उसके लिए ज़्यादा आसान है. Now, what about this one? Arrange the following orbitals in the decreasing order of energy. You have to use N plus L rule. अगर N plus L rules से दोनों के दोनों क्या आ जाए? Okay, जिसका N plus L ज़्यादा होगा, that is going to be having higher energy. If the N plus L is same for both of them, यानी कि दो ऑर्बिटल के लिए N plus L same है, then जिसका N larger होगा, will have larger energy. What is the N plus L here? N plus L here is 3. यहाँ पे कितना है? 4. यहाँ पे कितना है? 4. यहाँ पे कितना है? 5. बताइए सबसे एनर्जी ज्यादा किसको? You have got the answers. Okay. D डी का सबसे ज्यादा, उसके बाद बी का, है ना, डी बी। अच्छा, फिर ए और सी भी देखना पड़ेगा। देन वी हैव सी एंड देन ए। या डी इज द करेक्ट ऑप्शन। ठीक है ठीक है ठीक है ठीक है। वंस अगेन एन प्लस एल ही देखना रहता है ना। एन प्लस एल कैलकुलेट कर लीजिए, कितना हो जाएगा। 3 + 2 5, 4 + 1 5, 4 + 2 6, 3 + 1 4। ठीक है, तो सी में सबसे ज्यादा है, सी में 3 ऑप्शन सबसे ज्यादा, उसके बाद है ए बी। ए और बी में कौन ज्यादा है। डी विल बी लास्ट, तो ए और बी में से कोई ऑप्शन होना चाहिए, ए और बी। डी का सबसे कम है, उसके बाद किसका है। ए राइट, आफ्टर डी। 4 5 और 5 यहाँ पे है, 3 और 4 में से किसका कम है, ए का कम है। राइट, ए ऑप्शन विल बी करेक्ट, यस और नो।
Yes, sir.
Maximum number of electrons that can be accommodated in shell with n is equal to 4। कितने इलेक्ट्रॉन आ सकते हैं। स्मृता करेक्ट। अच्छा, इसका हम फॉर्मूला बताते रहे आप लोग को। मैक्सिमम इलेक्ट्रॉन इन nth शेल विल बी इक्वल टू 2n²। ठीक है, 2n²। मैक्सिमम नंबर ऑफ ऑर्बिटल्स इन nth शेल विल बी इक्वल टू n²। ठीक है, यहाँ ध्यान रखिएगा। नंबर ऑफ ऑर्बिटल्स इन nth शेल में कितने होंगे, n शेल तक में कितने हो जाएंगे, अगर 4 है आपके पास तो it will be n² and each orbital it has 2 electrons, so 2 into n² will give you the number of electrons। दोनों को याद कर लीजिएगा। So for this the correct option will be 32। Write this equation, sorry, write this question, sorry। What is the question saying? The wave function of 2s is given by this particular equation। बड़ा सा equation उन्होंने दे दिया। This is going to give you the 2s का क्या wave function। Now they're asking at r is equal to r0, जब r किसके बराबर हो जाएगा, r0 के बराबर, रेडियल नोड इज फॉर्म। क्या होता है रेडियल नोड, व्हाट इज नोड, नोड इज दैट प्लेस where the probability of finding electron is equal to 0। It is equal to what, it is equal to 0। That means psi 2s will be also equal to what, it will be also equal to 0। ठीक है, ठीक है जैसे प्लीज टेल मी। अब यहाँ पे आपको क्या
Sir,
करना
could
है,
you explain?
नहीं नहीं यहाँ पे देखिए ना, इतना समझ में आया। नोड इज व्हाट, द प्रोबेबिलिटी ऑफ फाइंडिंग इलेक्ट्रॉन इज 0। यहाँ पे क्या होता है, द प्रोबेबिलिटी ऑफ फाइंडिंग इलेक्ट्रॉन इज 0। ठीक है, दैट मींस
Yes, sir.
psi square will be 0, therefore psi will also be equal to 0। okay, now you need to plug in the value 0 here। यहाँ पे plug in कीजिए value 0। साइन स्क्वायर 0, अच्छा एक काम कीजिए, साइन स्क्वायर को 0 कीजिए ना, तो इसको स्क्वायर कर दीजिए, दिस होल टर्म को भी स्क्वायर कर दीजिए। सो यू विल हैव 1/2 रूट 2 पाई इंटू 1/a0 का रूट था, तो रूट का स्क्वायर हो जाएगा, राइट? रूट का स्क्वायर हो जाएगा, तो दिस विल बी एज इट इज मल्टीप्लाइड बाय 2 इंटू 2 माइनस r/a0 इंटू e टू द पावर माइनस r/2a0, ठीक है, इंटू 2 होल स्क्वायर था, इंटू 2 आ गया, तो यहाँ से ये भी कैंसिल हो जाएगा। नाउ यू विल गेट 1 नहीं, वेट अ सेकंड, सही से लिखने दीजिए हमें। साइन स्क्वायर विल बी इक्वल टू 1/2 रूट 2 पाई इंटू 1/a0 इसका रूट है।
So won't 1/2 root 2 pi also get squared?
हाँ, it will also get all the terms will get squared ना, एक सेकंड, हाँ,
Yes.
all the terms will get square। 4 इंटू 2 का स्क्वायर क्या हो जाएगा, 4 स्क्वायर इंटू 2 स्क्वायर, हाँ ठीक है। सो 1/2 रूट 2 पाई will be squared into 1/a0, 1/a0 to the power 1/2 into 2 क्या हो जाएगा, 1/a0 हो जाएगा, into 2 minus r/a0, this also will be squared into e r/2a0 into 2, these two will be cancelled, ये हो जाएगा 1/2 root 2 into 2 root 2, it was a 4 into 2 8 pi into a0 into 2 minus r/a0 into e to the power minus r/a0. Okay, now this whole term will be equal to 0. सही है, yes or no, please tell me guys.
Yes,
Correct है?
sir.
अब ध्यान से सुनिएगा, ठीक है, ध्यान से सुनिएगा। This term cannot be 0. 1/8 pi can be 0? नहीं ना? Can this be 0? No, right? अरे 1/8
sir.
क्या है? है ना, 1/8 is a constant, 1/pi is a constant. 1/a0, a0 is the, a0 क्या बताया था हमने, a0 क्या होता है, it is the first radius हाइड्रोजन एटम का, तो वो भी क्या होगा, that is also a constant, it cannot be 0. And e to the power minus r/a0, this also cannot be 0. Correct है? Yes or no, please tell me guys.
Yes.
Yes, sir.
That means only this term can be 0. 2 minus r/a0 will be equal to 0, right? And hence I can write 2 is equal to r/a0, and क्या relation है? r0 will be equal to